Hi all, this is Harini. Welcome back to our YouTube channel Code with Harini. Today we are going to solve day 29 challenge, smallest subarrays with maximum bitwise R. So we will be giving an integer array nums of length n, which will consist non-negative integers. So for each index we'll go from 0 to n minus 1. So we have to determine the minimum sized non-empty subarray of nums starting at index I that has maximum possible bitwise R. At any particular index from this index, what is the subarray that contributes to the maximum R? So here if you see 102 contributes to the bitwise R 3. Even if you take 1012, still it is 3. 10213, still the bitwise R is 3. So with the minimum sized 102 itself gives us the maximum bitwise R, right? So we have to return this subarray length 3. So yeah, that is how we have to return the part from that particular index, what is the maximum bitwise R. Okay, for this 2, for this 0, we will be considering after this what is the subarray that contributes. So if you see here the same 3, 1, 2 will contribute to the maximum R. 3, 4, 2 to 1 itself will contribute to the maximum R. So this length is 2. Here 1 from this index 1, 3 contributes to the maximum R. 2. For this 3 itself will contribute to the maximum R3. After this there is no subarray exist as well. Whatever the value was there, that will be taking for the last index. So for example in this, let's see for the nums 1, 2. So if you take this whole subarray, our maximum R will be 3. So 2. If you take 1, our maximum R will be 1. If you take 2, our maximum R will be 2. But if you take this 2, our maximum R will be 3, right? So we have to from that particular index will be keep on having the subarray. As we know, we'll get maximum R when we include to the max all the elements, but sometimes the same elements might be repeated, like here 1 is repeating again. Okay, so 1 2 also contributes to the 3. Even if you include 3 also, the maximum R can be 3. So in some cases, uh, with the minimum subarray itself will form the maximum R. So in that case, we have to return the minimum size subarray. If not, you should take an into account or to the max whatever the values that can be possible for the particular index. Okay, for this 2, after this 2 there is no element exists. So to the maximum R can be possible here is 2 only. So 1. So to the max any subarrays the resultant end array will be 1, and that is the maximum R is possible. So now let's take a look at how this works and how we are going to approach the solution. Okay, now I have taken this as an example 10213. So, as we discussed earlier, subarray for this particular index, what is the possible subarrays? It can be 10 or it can be 1, 102, 101, 103. So, if you take 1 alone, our maximum R will be 1. If you take 10, still our maximum R will be 1. If you take 102, our maximum R is 3. If you take 1021, our maximum R is still 3. If you take 10213, our maximum R is still 3. So in that case, we have to return minimum sized subarray that contributes to the maximum R. Maybe if the value here would have instead of 3, if it here instead of 3, if it was 4, our maximum R will be 4 for this particular subarray. Then you have to take 1 2 1 4 includes, right? So yeah, in that case our maximum R will be 4, and which increases this value. So you have to include the maximum R value subarray, right? In that case, it would have been, the length would have changed to 5. Here, now already by with this subarray we are getting 3. We don't need to include further more because that doesn't increase our maximum R value anyways. Okay, so next for this particular index, now you can't take this one. From this index, what are the values exist? So the same 0, 2 contributes, 0 contributes to the maximum R 0, 2 contributes 2, 0, 1, 2 contributes 3. So there is no point of taking 3 into account. So this is also to the max 3. So here for 2, if you take only 2 alone, then our maximum R is 2. If you take 2, 1, it's 3. If you can take 2, 1, 3 as well, but still that doesn't contribute to any extra to our maximum R value, right? So we can just take 2, 1. That is a minimum subarray and that contributes to the maximum R value. Same for 1. If 1 and 3 exist, so if you take 1 or 1, 3, if you take 1, our maximum R is value is 1. If you take 1, 3, our maximum R value is 3. So we are taking 1, 3. So then for 4, we don't have the choice. Whatever the leftover the value, that is the maximum R value. So we'll be just taking 3, but the length is here 3 and here 2, 2, 1. So this is our resultant array that we need to return. So in this case, if you see 1, 2, if you include 1 alone, our maximum R value will be 1. If you include 2, our maximum R value got increased. So we have to, the subarray should have maximum R value, and if possible, we can minimize the subarray. So here we have minimized because if you take full array, still the value is same. So here if you include 2, the maximum R value is changing, right? So we are taking 1, 2 and this contributes to the 3 and the length is 2. So now I will come here, it has only 1. So the maximum R value is 2 and our length is 1. So we have to return 2, 1 as a result. So now if you just see, it's not like all, here we have all the max or value as a 3, but it's not like all the max or should be the same value. No, from that particular index, whatever the subarrays that you can form and max or of that value we should take. So here the max are at any point at any index it is forming 3. But here if you see at the last index we are getting max r as a 2, but there's no further more nums that we can calculate whether more than 2 that max r exist or not. Got it? Okay. Now for this, how we are going to approach? We know we have to traverse from this to from this index to this index to this index. All this we will be traversing. For this, we have a possibility of, okay, you can do r of this, you can take this and this. For this, you have only 4. For this, you have only 3. For this index, you have only 2. For the last index, we have only 1. So now to the max, they have 2. Terms of I value will range till 10 to the power of 9. So it means it won't cross 31 bits. Okay, so what we will be doing, we'll be taking a bit of length 32, and for each num we will be storing what is whether the bit got set by any number. For example, this is the bit value for 3, right? So now at which index this bit got set? 4. So first and second bit 0th and first bit got set at 4, 4. Okay, so to this element we can take to the last index we can take only the last. Other than that we can't take anything. So but if it is for 1, you can take one bit as well as whatever the bit got set for the third as well. So if you traverse in a reverse way, we know, okay, if this for 3 I have the bit at 0 and 1. For 1 I have a bit at 0. Okay, what we will be doing now, you will be like, okay, for my 1, for this index I have a bit at 0, but we have to find out the max r. How we'll figure out the max r for this particular one? So we will be checking to the max how many bits got set for the other. We'll be traversing through the all the array. If any bit got set here, in if you are traversing in the 32 bit, if any bit got set, for example in this case, uh, for the value 1, we will be having only 0001, right? So in this case, um, we are checking, is there any other max or possible? Yeah, obviously it is possible, because that for 1 you can have 1 3. So now if you consider only 1, our max r will be 1. But if you consider 3 as well, our max r will be 3, right? So but I already traversed these 3, and I have said for the 3 is what are the bit got set 0 and 1. So I have told, okay, this first bit got set already by the last value. So if you taken this as a subarray, we can know, but now we know, okay, our starting index is 3. Okay, this is the starting index. So now uh, tell where, if for example if you assume it has 9, tell 9 array, and if some other bit got set here, let's assume, okay, this is at set at 6th. So now if you see, right, okay, now the 7th bit got set means at particular index 6, my 7th bit got set. Okay, which means by, if you are when you are doing r, okay, of 1 is nothing but this, right? Now our answer will be 129, right? Our maximum r will be 129. So that's why we'll be traversing from n minus 1 to 1. So for we, as we discussed earlier, for this particular index we can take whatever the values that is available on the right. So now if you traverse from the right, and if you keep on setting those bits at which particular nearest index this bit got set, okay, so we'll be getting the smallest subarray. We should always have the nearest bit set position to the same. Anyway, to the max, this 188, 128 bit can be set at anywhere. Yeah, initially, let's assume the 7th bit was initially first, it would have got set by 9th. Okay, we will have 9. Then, when traversing 7, also this bit got set. Okay, then what we will be updating the same bit, if it got set by the current I, you should update to that I. Okay, now it got updated to 7, which means, so if you each subarray should be a contiguous, right? So for this particular index, if you take 7, our subarray will be 7 minus 3, 4 sized. If you consider 9, our subarray will be 9 minus 3, which is 6. So we have to consider the small subarray. The same bit is present in both. So yeah, like this only will be, this is the approach we'll be using. Will be keep on traversing from the last value to the first, and we'll be keep on setting up to the max what all the bit got set for this particular value, this particular value, this particular value. Because 3 and 4, now this will be like 3, this index is 3. To the get max r value, r we will be at the end 4 minus 3 equals 1. Okay, 1 4, so j minus I plus 1, something like that. So now the our array is 2. Now when this 2 comes, okay, where this first, now this bit is set to 3 and this first bit is set to 1. So 2 is nothing but 1 0. So first bit is setting by the nearest index itself. Okay, so now this will be 4 will be getting updated to what is the index position at that point. Got it? So now if it got updated to 2, okay, next. So to the max, we should keep on. It's not like we should always take only the bit that presented farther index. We to the max how many bits was set, that will increase our maximum R value. Even if you see here, if you take only 2, our first bit got set. Okay, but 0 bit got set at the at with 3. So by with 3 our XR value got increased to from 2 to 3, right? So we have to consider what all the bits set till 0 to 32 and what is the nearest bit, nearest index that contributes to the corresponding bit that we will be taking. So now here for the farthest is 3. Okay, for this 2, now it got updated to 2. Now third bit got set to 1. Still the fourth bit also there's nothing but fourth bit also set the same bit that got set by the 2. So it won't get updated. Then all these bits were not set. So now what is our farthest index, which is 3. So 3 minus 2 plus 1, same, it contributes to the value. So like this we'll be keep on traversing and we will be updating our what is the nearest index. Yeah, that's it. I hope this makes sense. This is the exact solution that we have used to solve the question. The solution that we are used to solve this question. So the same example, if you take 1 0, if you see, this is our array. It will go from 3, let's assume our I. Okay, farthest is, as we discussed, at any particular point. Okay, if you, as we initially told, the from this index whatever that available on the next only we can take. So our first, our farthest to the max, this is the value that will have the all the bits that got set already. Okay, if not we will be taking any other values that contributes to the farthest bit, so that might increase our max or value. Got it? So now we'll be taking this 3. So 3 our farthest is the here I comes, farthest is 4. So now bit will go from 0 1 2 3 and it will keep on checking nums of I to the max. If you are doing shift left to the B, that will basically what it will. Okay, this is 8421. Nums of I is 3. So for now, at that particular index, you will be doing right shift. So this will come whatever for now it is. For example, let's assume it is 1. So 0 0 1 for one time you have to do the shift left. So what it will happen, whatever the first bit it will come to the last. Okay, and if you are doing 0 0 1, you will get that particular bit is set or not. Got it? If initially it is 0, so there is no shift left. So if you are doing, we'll be checking 0th bit is set or not. It is set. So what we will be doing, we'll be updating the index. So latest of B, this is the latest. Okay, so why you're not checking what is the minimum here, because this should have the minimum, right? So if you are traversing from right to left, whatever that particular I, that will be the to the max the minimum. So you don't need to check whether whatever value here and whatever value that we are going to be insert as minimum or not, because we are traversing from the right to left. So at that particular I will be whatever comes will be the minimum. So initially now if this bit is set, you will be doing. If not, if latest be not minus 1, then okay, this bit is not set by this particular index. We are getting that bit from somewhere in the right that contributes to the max R. So we'll be checking our farthest. Okay, for example, this bit to the max, we should take all the bits that got set. Okay, this first bit would have got set at 7th position, fourth bit would have got set at index 5. Still we have to take this into account, that will contribute our max r, right? So 7. So whatever comes, whatever is not set by the current bit, and whatever the for that particular index, how many bits got set, whatever among it is maximum, that will be our farthest point. Okay, so that we will be updating, well, that's why we are updating max, farthest, or current latest of b, which is, for now we don't have anything, we have all minus ones, so we'll have our farthest point as 4 only. So if a resultant of I is 4 minus 4 plus 1, which is 1. 1 is the, this is the one we are going to take at this moment. So our result will be 1 for 4. Okay, now I will be getting updated to 3. I is 3. So farthest is 3. B initially will go from 0. So for 1, what is only first bit will be set. So now, okay, for 3 we would have set 2 bits, 0, 8421, 0 as well as 1. Okay, both will be would have got updated by 4 4. Now for 1 we will get only 1 as a first bit is get set, so this will get updated to 3. Okay, so the nums of I and 1 initially will get give updated to 3, latest of b, which is 0, then it will go to b, comes to 1. So but this build is 0, right? So like this, among it will traverse through 31 bits, all will give 0 0 0. But other than first bit, all other bits are minus 1, so that will not impact, but first bit is not equals to minus 1. So when b equals to 1, that is not minus 1. So farthest is current is 3, but the latest is 4. So this now increase our max r value. Currently max r would be 1. Now if you include this bit, our max r will be getting incremented to, it will obviously increase. We are not calculating the max r value, but if the bit is set, number of bits set increases our max r value, so we know okay this bit is set. So our farthest now get updated to 4, whatever the latest of b, which is 4. So 4 minus 3, then it will traverse through all the loop, our farthest will be just 4 because all are minus 1. So 4 minus 3 plus 1 gives us 2. So this 2 is nothing but 1 and 3 contributes to the max R value 3. Got it? I is 2. Okay. So what is the value also 2? So 0 0 1 0. This is the 2 contribute. So at first, when b comes 0, our bit is 0. But we know, okay, some point this bit got set, which is 3. Our third index, this bit got set. So our farthest is currently 2. At third index, this bit got set 2 comma 3. Now the farthest will get updated to 3. Got it? Okay. Once the 3 got updated, now the b will go to 1. This bit is already set. Okay. But this bit is already set by other uh, element that is present in the right, but still we should take what is the minimum, right? This itself sets why we have to take farthest, so which will increase our subarray length. So now I'm just updating this to 2. So now we are checking the still 2 is, what is the farthest index, still 3 is the farthest. So like this it will go, still all this are minus 1, so farthest is, there is no point that farthest will change. So 2 minus farthest is 3 minus 2 plus 1, which gives us 2. Now we know, okay, this 2 1 only it has taken, so now it will come to 1. Our father's currently is 1 0, so 1 means value is 0, so there is no index that is got set, that is there is no bit that is set by this value. So to get the maximum, first initially will be, okay, this is 3 and this is 2. So first initially our fathers will get updated to 3, the nums and this will be 0, is not true. So the latest of B will not updated with this index to any of the bits. So already this 2 bits is set. So in this farthest is 3, that will get updated here. So same 3 minus 2 plus, sorry, 3 minus I is 1 now, which is 3. Now, okay, including this, now where the max R comes to the max 3, even if you include 3, there is no point. That's why we keep on updating the bit index that is nearer to subarray. That's why we are traversing from right to left as well. Next 1 comes. Okay. 1. Okay. 1 here 1 comes. So we know 1 is already set by the current index. So there is no need of this one. So instead of 3, now we'll be getting updated to, okay, the farthest index among all will be getting updated to 2, as we know once we traversed from 0 to 32. Now the farthest index is 2. So 2 minus 0 plus 1 gives us 3. So we know, okay, this is the length. This is the subarray that contributes to the max R value and gives us a result 3 that we will be updating in this. So these are the resultant array that we are returning at the end. So yeah, I hope this makes sense. Why basically we are not doing anything except we are traversing from the last to first, because at that particular index whatever the right bits, the right elements that is present, whose bits value has more number of bits, that we will be taken into account. So to uh, so we are storing that index. So whether by including that index we are getting more or value, then you keep on storing the further. But if the same bit is set by the some other value while you are traversing from right to left, we know, okay, this by this bit itself we are getting that particular r value. Why to include the farther index? So that will increase our subarray length, right? Yeah, that's what we are basically doing. I hope this makes sense. I hope you guys would have understood why we are traversing from right to left, why we are taking farthest index, everything. So the time complexity for this is order of n cross 32. Space complexity is 32. Yeah, that's it. If you have any questions, please do leave a feedback in the comment section. I'm happy to help. Also, if something could have explained better or any part that you guys didn't understand, please let me know in the comment section. If you do like my video, please do like, share and subscribe. Yep, thanks for watching.